So last question on the paper, question 10, and this one's on projectiles. So it says a boy throws a ball at a target. At the instant when the ball leaves the boy's hand, at the point A, the ball is 2 meters above the horizontal ground and is moving with speed u at an angle alpha above the horizontal. So we can see that in the diagram there. In the subsequent motion, the highest point reached by the ball is 3 meters, that's on the diagram as well, above the ground. The target is modelled as being a point T, as shown in figure 4. The ball is modelled as a particle moving freely under gravity. Using the model, show that u squared is 2g over sine squared alpha. So what we're first going to do is use SUVAT for the vertical, SUVAT. So we know that u, the initial vertical velocity, is capital U sine alpha. V, well, we're going to consider the particle at this point here, its highest point, when it's turning, which is velocity 0. Acceleration, if up is positive, is minus g. And we're considering all this when the displacement above where it started is 1 meter. So t is irrelevant to this. So it said show that u squared equals that. So we use v squared equals u squared plus 2as. So writing that equation down, v squared equals u squared plus 2as, and then subbing in numbers, we've got 0 squared equals u squared sine squared alpha plus 2as, where we get u squared sine squared alpha equals 2g, which means that u squared equals 2g over sine squared alpha, which is what we were asked to show. So the next part, it says the point D is a horizontal distance of 20 meters from A and is at the height of 0.75 meters above the ground. Let's get that on the diagram. And that there is 20 meters, and this one here is 0.75 meters above the ground. So let's consider the particle when it's at this point here. So we'll consider vertically again. So we've got S U V A T, and its displacement from its original position now is minus 1.25, because it was at 2 meters at the start and now it's moved down 1.25 meters, so minus 1.25. Its initial velocity, u, is u sine alpha. Its final velocity we don't know. Its acceleration is minus 9.8. So let's find an equation that links those variables there. So we've got S, U and A. And let's try and relate them to T. So we've got S equals ut plus a half at squared, t plus 1/2 at squared, which means that minus 1.25 equals u sine alpha t plus a half a t squared, which means that minus 1.25 equals, and let's just reorder these terms a little bit, ut sine alpha plus and a half of minus 9.8 is minus 4.9, minus 4.9 t squared. Then turning that into a quadratic, taking everything over the the left hand side, we get 4.9 t squared minus ut sine alpha minus 1.25 equals 0. Now let's do the same thing horizontally. So horizontally, S U V A T. So we want the displacement at 20 meters. The initial velocity is u cos alpha. The final velocity Well, because the acceleration horizontally is 0, we know it's also u cos alpha, and t we don't know. So, again, s equals ut plus half at squared. So s equals ut plus a half a t squared, and that term disappears to get that 20 equals ut cos alpha. Which means that, and we can rearrange this to nicely say t equals 20 over u cos alpha, and now we can sub that into the other one, which means that 4.9, I've got 20 squared over u squared cos squared alpha, so 400 over u squared cos squared alpha minus u times t, which is 20 over u cos alpha times sine alpha minus 1.25 equals 0. Right, so 4.9 times 400, 4.9 times 400 is 1960, so 1960 over u squared cos squared alpha minus, the u's cancel, 20 over cos alpha times sine alpha minus 1.25 equals 0. And the aim here is to try and eliminate everything except alpha. So, which implies that 1960 over, and u squared we worked out in a previous part. Where have we done it? Just up here. U squared we worked out to be 2g over sine squared alpha. So this u squared here we can replace with 2g over sine squared alpha. So that's 2g over sine squared alpha, that's u squared, times cos squared alpha minus 20 sine alpha over cos alpha. Probably going to have to turn that into tan in a little while, but we'll make a judgment in a second. Minus 1.25 equals 0. So dividing by a fraction is the same as timesing by its reciprocal. So that becomes 1960 times sine squared alpha over 2g times cos squared alpha. Take away 20 sine alpha over cos alpha minus 1.25 equals 0, which then means that we're almost there. So notice that the question didn't say show full working, therefore it's acceptable now just to put this in the quadratic solver in the calculator. So going straight to the quadratic solver, first coefficient is 100 minus 20 minus 1.25. Let's see what that gives us. So it gives us tan alpha equals a quarter, or minus 1/20th. Tan alpha equals minus 1/20th. Well, actually we can discard that because we're not going to project it in a negative angle. Right, so tan alpha is that, so the angle alpha equals arctan of a quarter, which is equal to arctan of 1/4 equals 14.04 degrees. Getting towards the end now. So part C, state one limitation that could affect your answer to part B. Well, even if you haven't answered any of the rest of the question, you could have had a go at this. It's always, the model does not take into account air resistance. To account air resistance. And the final part, D, which says find the time taken for the ball to travel from A to T. Well, we can find U using the formula u squared equals 2g over sine squared alpha, which means that u, which we know is a positive quantity because it's the initial speed, equals 2g over sine squared alpha rooted equals the square root of 2g over sine squared 14.04. What we're going to do, we're going to use the more precise value that we got from the calculator. So equals, let's put that there, the square root of 2g over sine squared 14.04. What we're going to do, we're going to use the more precise value that we got from the calculator. So equals, let's put that there. So we've got the long angle in the formula in the calculator from the last time. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.